Okay, so in this video, we're going to show how you can do automatic evaluation in LangSmith. We just showed you how you can easily collect data sets in LangSmith. As a reminder, these are inputs and outputs that someone has deemed as a good response. So if your agent was given this question and it output a response like this would be considered a golden answer or a true reference data set. And so we make it pretty easy for you to create test runs in LangSmith. This is really the only way that you're going to be able to gain confidence that you can put that application in production. You have to observe over dozens of inputs, how your agent performs, and see if it meets your criteria bar on the quality side or accuracy side. So we have a couple evaluators that you can borrow that are off the shelf, like correctness. You can test for things like helpfulness or insensitivity. And all that we're doing here is really building up some evaluators that we can copy into our LangChain code. Often evaluation, though, is pretty bespoke to your business, and we give you space to create custom evaluation as well. Maybe it is that your output needs to be proper JSON. So you might want to test that it runs through a JSON deserializer properly, or maybe you want to test that it runs through a SQL linter properly. But we really let you, as your business, define exactly how you want to evaluate these runs. And this is where often the really hard work happens to test over thousands of examples and build that confidence. So we can copy this code into LangChain, which we'll do now. And in this eval example that I have, what's happening is we're using the same agent that we've used prior, and we are going to evaluate it on a few criteria. In this case, the correctness, insensitivity, and helpfulness. We're going to use a higher level model, in this case GPT-4, to do the grading. So a lot of the automatic evaluation can be done with an LLM grading the output. And so people like to pick a more cognitive LLM to do the grading, and GPT-4 is an excellent choice. Then you name a reference data set in LangSmith. So this was the planetary successful data set that we've been working with, and you're going to give it a name. And because I am less creative, I will just use the auto-populated name that we are given here. And I can run it. And I can see I have something running already, but I can just pause and rerun from the top. Okay, so we're going to rerun this code. And the other thing I wanted to point out is that I've added a tag. And this is really important to keep track of what's being run. So in this case, I'm using GPT 3.5 under the hood. So I've noted that here. Now my test runs will be tagged with GPT 3.5. Often people will also tag the commit SHA for the prompt. And that way you know what prompt was running when you are testing a particular iteration of a prompt or an iteration of a chain or agent. You'll have precise information of what you're actually testing against. So let's go ahead and run these. And we can see in LangSmith, there's a new test run that's happening now. And these usually take a minute to run, but we already see it's started and it's kicked off. I'm going to actually use a run that I just ran to walk through that's completed, but we can quickly see that in these runs, we have some aggregate measures for the correctness. So only 38% of these test runs came back correct. 0 were insensitive, and only 63 were insensitive. 63% were helpful. So I can click in and really get much more information on what's happening. So you can see these are the inputs that are in the data set. And really, this agent is just getting iterated over all of these inputs, and it's getting compared. The output of that agent compared to the reference dataset output, which is also tagged here, was this response that the agent provided correct? And we see a lot of times that it was not correct. And so this is a comparative evaluation. We'll click in and show what that looks like. So we can see that given this input, this agent responded the following, but the reference output said, the response was something different. And we could see that, in fact, the score for correctness here was 0. It wasn't helpful, but it wasn't insensitive at least. But if we wanted to click in and see how these evaluators are actually doing the evaluation, we can see it's really just another LLM run. And so if I click into this helpfulness run and I dig into the actual prompt that's being used, you can see that it has some prompt around, given this submission and describing what helpfulness is this submission meet your criteria for helpful? And it replies, why, meaning yes, it was helpful. And that just gets recorded really easily on that particular run. So that way we know that this run was helpful. But this makes adding evaluation a lot easier. And just to kind of double click on a few more runs to show it in action, not all evaluation criteria is comparative in nature. Certainly correctness is. And in this example, we did get that the answer was correct. And you can see just by eyeballing it, the output that this agent gave compared to the true answer, the reference output, both got 10. So it's automatically rated as correct. Even though, these are pretty semantically different responses, and maybe the distance of these two embeddings might not be that close, you did get the correct response. And so this all gets added to your test runs, and you can get these aggregate measures around helpfulness and sensitivity and accuracy because those were the measures that I asked you grade on. And one of the things that I really like about the test runs in LangSmith is I can iterate and tweak my chain or agent and continue to run it. So in this run, it's now completed in the background. Remember, this tag was GPT 3.5. We could see that it ran, and it was helpful 88% of the time. It was not insensitive, and it was accurate 100% of the time by this measure. And if I compare these two test runs, I can even get a much deeper view of, where did they differ? So if I want to filter around a run where it was maybe not correct, so a contextual accuracy of 0, by removing this one, I can see how this agent performed when it was incorrect versus this agent using a different underlying model did get the answer correct. And I can just read right across, given this input, given this reference output, these two versions of my agent, as I tweaked the underlying model, they had different responses. And I can comb through as a reviewer to see exactly how they differed. And sometimes you'll see that the LLM grading wasn't accurate. These are two pretty similar texts, but when we scored via the LLM, we got it said it was 0 here, so it wasn't accurate, even though it said it was accurate. In this case, you're not always going to get perfect responses by the LLMs, but I'm able to really narrow down the number of rows that I need to look at when I'm comparing between two different test runs and seeing how, as I iterate and change my chainer agent, whether it be a different underlying model or a different retrieval strategy or a different prompt, I can pairwise see how the responses change.